Astronomers have discovered an exceedingly old star at the edge of our galaxy that seems to have formed only a few million years after the Big Bang, and what they are learning from it could affect their understanding of the birth of the universe. In a study published last week, researchers found the star during an astronomical survey of the southern sky with a technique called narrowband photometry, which measures the brightness of distant stars in different wavelengths of light and can reveal stars that have low levels of heavy elements. They then studied the star, known by its survey number as S+J 210,428.01-004934.2, or S+J 2104-0049 for short, with high-resolution spectroscopy to determine its chemical makeup. S+J 2104-0049, a red giant star with about 80% of the mass of the Sun, is at least 10 billion years old and possibly just a few million years younger than the universe itself, which astronomers estimate is 13.8 billion years old. The researchers used data from an astronomical survey conducted by a telescope at Cerro Tololo in northern Chile. It revealed the star in the halo of our galaxy, far beyond the main disk of the Milky Way and about 16,000 light-years from Earth, much too far away to be seen with the eye. The initial survey covered about 20 million stars, from which he selected about 200 to be investigated with medium-resolution spectroscopy using Neurolab's Gemini South telescope, a few miles away on Cerro Pacán in the Chilean Andes. S+J 2104-0049 stood out as particularly interesting, and so was investigated further with high-resolution spectroscopy using the US-operated Magellan telescopes in Chile's Atacama Desert, about 100 miles further north. The observations show that S+J 2104-0049 is extremely poor in heavy elements and that it has one of the lowest levels of carbon recorded. That implies that it is a very early population II star that formed from the remnants of exploded population III stars, the very first population of pristine stars, containing only hydrogen and helium, that formed only a few million years after matter was created in the Big Bang. So far, no one has found a population III star. The larger a star's mass, the more quickly it burns out, and it's thought most population III stars were extremely large and burned out long ago. Most stars, such as the Sun, are third-generation population I stars that contain relatively heavy elements such as iron, nickel, carbon, and oxygen. Those heavy elements were created by fusion within population II stars that exploded as supernovas and seeded them into interstellar clouds. Our Sun, which contains around 2% of its mass in the form of heavier elements, is estimated to be 4.6 billion years old. Astronomers think it has another 5 billion years to go before it swells into a red giant star that will engulf the Earth and then shrink into a white dwarf star. Modeling of the conditions that S+J 2104-0049 formed under suggests it coalesced from an interstellar cloud polluted by the supernova of a single population III star with about 30 times the mass of our Sun. The models also suggest that the population III star that it formed from had a different fusion process than expected, which could lead to a greater understanding of interstellar conditions in the early universe. The discovery shows the value of the narrowband photometry surveys for identifying ultra-metal poor stars and suggests that even more could be found. It's even possible that searching in this way could lead to the discovery of a genuine population III star that formed soon after the Big Bang, although it would need to have the mass of the Sun or smaller to have survived so long without burning up all its fuel. S+J 2104-0049 was likely to be very old indeed, and might even be older than the oldest known population II star, dubbed HD 140,283, or the Methuselah star, but it will be very difficult to actually determine its age because it is at a relatively large distance. Meanwhile, the search for the original population III stars continues. Nobody has found a truly pristine star made only of hydrogen and helium.